Welcome to Rediscovery, where the wonders of space and science ignite. Explore the unknown, embrace the thrill, and get ready to dive into today's epic adventure. Imagine a nuclear explosion. You probably picture a giant fireball, a deafening roar, and a devastating shockwave. That's what happens on Earth. But in space, it's a whole different story. Space is a vacuum, empty of air. No air means no oxygen to fuel fires. Sound can't travel without a medium. So, a nuclear blast in space wouldn't be as dramatic as we see in movies. There would be no fiery inferno or ear-splitting boom. Instead, you'd witness a brilliant flash of light, a burst of radiation, and a rapid expansion of energy. The energy would spread out in all directions, but without air, there would be no shockwave. The particles would move outward, creating a beautiful but silent spectacle. Any debris from the explosion would float away, unaffected by gravity. The lack of atmosphere means no firestorm, no sound, just a silent, radiant burst. It's a reminder of how different the cosmos is from our home planet. A nuclear explosion in space is truly a different beast, a phenomenon that defies our earthly expectations. It's a stark contrast to the chaos we associate with such an event on Earth. In the vast emptiness of space, even the most powerful explosions become silent, almost serene. A different beast indeed. Instead of a fireball, a nuclear detonation in space would produce a spherical burst of intense light and radiation. This flash would be incredibly bright, but it would be over in an instant. The absence of an atmosphere also means there's no shockwave. On Earth, the shockwave is responsible for much of the destruction, but in the vacuum of space, the energy from the explosion would radiate outward in a sphere. Without an atmosphere to carry sound waves, the explosion would be eerily silent. No roar, no rumble, just a silent flash of light. The lack of air also means no fireball. Fire needs oxygen to burn, and in the vacuum of space, there is none. So what you get is a burst of light and a wave of radiation, but no fire, no sound. It's a stark contrast to the devastation we see on Earth. Here, the atmosphere amplifies the destruction, carrying the shockwave and sound waves far and wide. But in space, the vacuum swallows the sound, leaving only the light and radiation to tell the tale. No fire, no sound, just the silent, brilliant burst of energy. Although there's no fire or sound, a nuclear explosion in space is still a terrifying release of energy. This energy takes several forms: intense light, heat, and various types of radiation. The light and heat, while traveling at the speed of light, would dissipate quickly with distance. The real danger comes from the invisible radiation, particularly X-rays and gamma rays. These can travel thousands of miles, damaging satellites and harming astronauts. One of the most significant effects of a nuclear detonation in space is the electromagnetic pulse, or EMP. This phenomenon, often overlooked, can have devastating consequences. This burst of electromagnetic energy can disrupt or destroy electronic equipment even at vast distances. The EMP can travel at the speed of light, affecting satellites and ground-based systems almost instantaneously. Imagine a future where our satellites, crucial for communication, navigation, weather forecasting, and many other aspects of our lives, are fried by a single, high-altitude nuclear explosion. The ripple effects would be felt globally. The consequences for our technological civilization would be catastrophic. Power grids could fail, communication networks could collapse, and essential services could be disrupted, plunging us into chaos. This is not science fiction, it's a real threat. The vulnerability of our space infrastructure to such attacks is a growing concern among scientists and policymakers. Understanding the unique dangers of nuclear weapons in space is crucial for preventing such a catastrophe. International cooperation and stringent regulations are essential to safeguard our space assets. By investing in research and developing protective measures, we can ensure the safe exploration and use of space for all humankind. The future of our technological civilization depends on it. Thanks for watching Rediscovery, where every journey uncovers breathtaking wonders. Craving more thrills? Smash that like button, drop a comment, and hit subscribe. Let's continue exploring the unknown together. Your next epic adventure is just one click away.